Hello my dear students. In this video we are going to learn about the chapter sound. So first of all we must understand that what is the meaning of sound. So sound is that form of energy which produces the sensation of hearing. Whenever we strike a surface, it produces the vibration in the particles of the medium, as a result of which the to and fro motion happens in the particles. This to and fro motion of the particles known as vibrations reaches to the membrane of our ears and produces the sensation of hearing. Now, the sound wave is produced in the form of a longitudinal wave and is transferred from the source to the receiver in the form of compression and rarefaction. Compression and rarefaction. The factors which are linked with the term sound are loudness. The first one is loudness. Second one is called pitch. And the third one is called quality of sound. Quality of sound. After knowing the three factors which are loudness, pitch and the quality of sound, we are going to understand them one by one in detail. So first of all, I am going to make you understand about the term loudness. Loudness. The loudness of a sound is directly proportional to the loudness of the sound is directly proportional to the amplitude of vibration. If the amplitude of vibration is more, a louder sound will be heard. If the amplitude of vibration is less, then we'll hear a feeble sound. Here, A1 is greater than A2. So, the wave A will be louder than wave B. Now, the other factors which affect the loudness of the sound are, first, the sensitivity of the listener. The sensitivity of the listener. If the listener is very sensitive, then a louder sound will be heard to the listener. But if the listener is having some problem in his ears or he is not attentive, so he will listen to a feeble sound. The second factor which affects the sound is amplitude of wave that we have seen just now. Amplitude of wave or the vibrating particles. Loudness is directly proportional to square of amplitude. The third factor is the distance between the source and the receiver. If the receiver is standing close to the source, then he will hear a louder sound. If he is standing away from the listener, from the source, then he is going to listen to a feeble sound. So the three factors which affect the loudness of sound heard by a person, by a receiver are, first one is sensitivity of listener, amplitude, in which we can see that loudness is directly proportional to square of amplitude. Then we have the distance between the source and listener. The source of sound and the listener. So these three factors affect the loudness of sound heard by a person. After this, we are going to understand about the second factor which is related to sound, and that is pitch. So pitch of a sound is related to the frequency of the sound, and frequency means the number of vibrations in a 1 second. The pitch is related to frequency of sound, and frequency is the number of vibrations in 1 second. So here I am drawing two waves having almost same amplitude. So here we can see the number of vibrations in the given time is less. Here the number of vibrations is more. So if I'll tell them sound A and sound B, vibration A and vibration B. So the sound A is of low pitch, it is a low pitch sound. The sound B is high pitch sound, it is a high pitch sound. Why sound B is a low pitch sound? Because this is having low frequency. So that is why this sound, a low pitch sound, appears to the person as a flat or grave sound. It appears as flat or grave and is generally seen in case of men. The men have a flat sound, they have a grave sound because their frequency is less, their pitch is less. Here in this case, we have a high frequency, so this sound will be heard as a shrill sound. It's mostly heard in case of women and it is having high frequency. This sound is having high frequency. This will be a shrill sound and is seen in case of women. Now the question comes that how the pitch can be changed in case of the different musical instruments. We have different kinds of musical instruments like the stringed instruments or the membrane instruments. Okay, so we'll see that how we can change the frequency in case of a stringed instruments like a guitar. So in case of stringed instruments, there are two factors which affects the pitch of the sound. The first, we can change the pitch of the sound by changing the tension in wire. The tension in wire. If the tension in the wire is increased, then the pitch of the sound will also be increased. If the tension is decreased, then the pitch of the sound will also be decreased. The second factor is the thickness of the string. The thickness of string. If the string will be thick, a low pitch sound will be produced. If the string is thin, a high pitch sound will be produced. Okay? Then it is inversely then the pitch in case of the wind instruments like flute or clarinet. Here the frequency I am representing with N is inversely proportional to the length of air column. The frequency is inversely proportional to the length of air column. If the length of vibrating air column is more, a lower pitch sound will be produced, and if the length of the vibrating air column is less, a higher pitch sound will be produced. This we can show by using a simple experiment in which I am using certain glasses A, B, C, and the amount of water in all the three glasses are different. A, B, C. Alright, so when we strike the glass A and record its frequency, then it strike B and C also, what we will notice that the frequency produced in case of A will be low. The frequency produced in case of B will be higher than A, and the frequency produced in case of C will be more than both A and B. Because here the length of air column is the least. This L is least, so the frequency will be highest. So here we'll have a high frequency sound, less frequency sound, and the least frequency sound will be produced. After this, let us understand about the quality of sound. Now, what is the meaning of quality of sound? Quality. Suppose two women are speaking or two men are speaking, and a third person is just hearing to the voice of the people from outside and the door is closed. But still that third person will be able to identify that which person is speaking at a time. Or simple example we can take that we can recognize the voice of the people even on the telephone without seeing the person. So this depends upon the quality of sound. Every person is having a particular quality of sound by which his sound is differentiated from the other person. That depends upon the waveform of the sound produced. They can be of the same loudness, they can be of the same pitch, but since the quality of waveform is different, so the voice of person A can be distinguished from the voice of person B. So we can have two persons which are having the same frequency but the waveform is different. So the sound of person A can be easily recognized or distinguished from the sound of person B. That is why whenever a harmonium is being played or a guitar is being played, since they are having the different kinds of waveforms produced by them, we can easily recognize that a harmonium is being played or a tabla is being played or a guitar is being played because of the difference in the type of waveform formed. This is known as quality of sound, which distinguishes one sound from another sound. Now we will discuss two numericals which are given in the chapter. So the first numerical is that there are two persons, two waves of the same pitch have amplitudes in the ratio 1:3. So A1 is to A2 is given as 1:3. What will be the ratio of their loudness and what will be the ratio of their pitch? So loudness, as we have now only discussed that loudness is directly proportional to square of amplitude. So here loudness is directly proportional to square of amplitude. So depending upon this formula, I can write down that L1 by L2 is equal to A1 square by A2 square. Alright. So now we'll put the values. L1 by L2 is equal to 1 square is 1 and 3 square is 9. So from here I am getting L1 is to L2 is equal to 1:9. Then the second part is to find out the ratio of their pitch. So since the two waves are of the same frequency, so that is why the ratio of their pitch will be P1 is to P2 will be equal to 1:1. This is the B part of the question. Because they have the same frequency, so that is why the ratio of their pitch will be 1:1. Now let us understand the numerical 2. It is given to us in the question that two waves have frequencies. The frequency 1 is given as 256 Hz and frequency 2 is given as 512 Hz. Two waves have frequencies 256 Hz and 512 Hz, but they have the same amplitude. So A1 is equal to A2. Now we have to find out the ratio of their loudness and the ratio of their pitch. So loudness. Just now we have seen the formula that loudness is proportional to the square of amplitude. And here both the amplitudes are same. So loudness will be in the ratio of 1:1. You can write down A1, let it be A. So we can write down A upon A, that is equal to 1:1. Now let us understand about the second part. This was first part. Second part, which is the pitch. So P1 by P2 is dependent upon the frequency. So it is equal to F1 upon F2. That is equal to 256 upon 512. So this is equal to 256, 2 times is 512. So 1 upon 2. So the ratio of P1 by P2 or P1 ratio P2 can be written as 1:2. Okay. So students, I just hope that all the topics that we have discussed is clearly understood to all of you. Thank you for watching.